Okay, so welcome back to another video. So in today's video, this is we got this monstrosity of an integral right over here. So we have that the integral from 0 to pi over 2 of the natural log square of e to the negative x squared divided by cosine x multiplied by 1 plus cosine 4x dx. So bit of a disclaimer, this video is going to be pretty lengthy. And so probably this has been the first time of this channel, or really in any math video in general, that I'm probably gonna have to erase some of my previous work to fill in for the next work, since there is going to be a lot of work involved. And another thing is that okay, so here that we got these 5 facts. So I simply wrote them down ahead of time, since not only that we're gonna need these, but I'm not actually going to prove these tools that we're going to need in order to help solve this integral over here. There's plenty of resources out there that you can check out yourself. You can even, especially, you can try integrating these integrals yourself. So we have the following 5 facts here. The first fact, the integral from 0 to pi over 2 of the natural log cosine of x dx is equal to negative pi over 2 times ln of 2. Second fact, integral 0 to pi over 2 times of x multiplied by ln of cosine dx equals negative pi squared divided by 8 times ln of 2 minus 7 over 16 multiplied by Apéry's constant, which is the summation of all the reciprocals of the positive cubes, aka the riemann-zeta function when s is equal to 3. Fact number 3, the integral from 0 to pi over 2 of x squared times ln of cosine x dx is equal to negative pi cubed divided by 24 times ln 2 minus pi over 4 multiplied by Apéry's constant. Fact number 4, integral from 0 to pi over 2 of ln squared of cosine x dx is equal to pi cubed divided by 24 plus pi over 2 times ln squared of 2. And last but not least, this is a pretty interesting one. The integral from 0 to pi over 2 of the natural log of cosine of ax multiplied by the natural log of cosine of bx dx is equal to pi over 2 multiplied by ln squared 2 minus pi cubed multiplied by the GCD square of these two constants a and b divided by 48 times ab. And this theorem, this only works if our a plus b divided by the greatest common divisor ab is an odd number as the result in order to use this. So we have all that discussed. So let's actually get into the meat of this video. Okay, so what we're gonna do is, there's an ln square, so I'm going to rewrite the following as a square, the square of the entire function. So 0 to pi over 2 of the natural log of e to negative x squared divided by cosine x, then 1 plus cosine of 4x, let's see, yep, and then that's bracket squared dx. Okay, and focusing on the inside, we can actually use our rules of natural logs to break our equation up a bit in terms of like natural logs. So to put it simply, we write the same integral, and so we have so basically using natural logs, I want the natural log of e to negative x square, and then b that, and subtract that natural with the difference of the natural log of 1 plus cosine 4x divided by cosine x. So e negative x square. Okay, and then well, simply this is addition, since this is products. I mean, I meant to say addition, not difference. So natural log of 1 plus cosine 4x divided by cosine x, and then square dx. All right, nice. Now next, how about instead we actually use our FOIL method to actually expand this expression out. So this means we have the integral 0 pi over 2. So simply we have the natural log square of e to the negative x square, then multiply the 2, so you get double the quantity, so this is plus 2 times the natural log of e to the negative x square, multiplied by the natural log of 1 plus cosine of 4x divided by cosine x, okay? And then multiply the outer, so this is plus natural log square of 1 plus cosine of 4x, and then divided by cosine x dx. Okay, nice. Now, we can actually use linearity to actually split this into several pieces of integrals, so that way we can evaluate each one separately. So in other words, I can just write this using linearity, so it's 0 pi over 2, and then let's see, this is the natural log square e to the negative x square dx, and plus I'll factor out 2 outside because of this, so this is 2 and 0 pi over 2, and then in here, so natural log e negative x square, then natural log 1 plus cosine 4x divided by cosine x dx, and then plus our integral from 0 to pi over 2 of ln square of 1 plus cosine of 4x divided by cosine dx. Okay, cool. So we have that. So now this means we have to compute each integral. So how about I label our integrals? So this means we're gonna let this first one. We're gonna let this one be I1, and we're gonna let this be I2, and then we're gonna let the last one be I3, labeled as follow. Okay, cool. Now, let's actually do this one by one, and let's actually first calculate the first integral, capital I sub 1. All right. Well, this should be pretty straightforward, so let me write out I sub 1 equal to 0 pi over 2 of ln square e to the negative x square dx. Okay. In other words, this is just the whole expression itself, then square, and then I'll just write it out just for sake of clarity. 2 of ln of e to the negative x square, then square dx. Okay, so that's what we have right here, and notice that ln of e will just be equal to it's just 1, so it'll just cancel, and then we're just left with the base of negative x squared. So if you square that, then you're gonna get a positive. So this is you're gonna get x to the power 4 dx, and then computing this step integral is straightforward. So it's 1 over 5 evaluated from pi over 2 to 0 to pi over 2. Put in 0, you're going to get 0, but if you plug in pi over 2 for x to the 5th, you're going to get pi to the 5th divided by 160. So that's equal to I sub 1. Okay. So there's a lot of things we got to evaluate. So how about instead, on the side over here, I'll put down what our value is for each integrated integral. So eventually when we're near to the end, we can actually combine the summations of everything together. So I sub 1, we have that it's equal to pi to the 5th divided by 160. All right, excellent. Okay, now we have that. I can just get rid of this. All right. Now the next thing we need to calculate is I sub 2. All right. So I sub 2 is equal to 2 times the integral from 0 to pi over 2 of ln of e to negative x squared, then multiplied by ln of 1 plus cosine of 4x divided by cosine x dx. All right, and so notice that the natural log of e to the natural log of e, that'll cancel, so we just get negative x squared. But instead, how about I actually factor out the negative, so that means the negative is outside the integral, so we get negative 2, then the same integral, well, now we have that it's x squared, then multiply by ln of 1 plus cosine of 4x divided by cosine x dx. All right. So now, focusing on this natural log expression, we can actually use our rules of natural logs, and we can actually, because this is a fraction within the input of the natural log, we can actually use the rules to actually subtract. So it'll be the difference of natural logs. So simply, this is just, so it's negative 2, 0 pi over 2, so x squared, and then this is being multiplied by the natural log of 1 plus cosine of 4x, then minus the natural log of cosine x dx. All right, that's nice. Then we can actually distribute the x squares into these natural logs, and then we get the following. And then we're going to do the same process as before. We're going to label each integrals as respectively to compute x squared natural log of 1 plus cosine of 4x dx, and then minus 2, or well, now it's positive since there's a negative, so plus 2 integral 0 pi over 2 of the natural log of cosine x dx. All right, nice. So we get this is, I'm gonna label this since we're at I sub 2, so how about I call this I sub 2 1, and then over here this is I sub 2 2. All right, cool. So now let's actually calculate our I sub 2 1. So okay. And just like before, as previous, after calculating the iterated integral, I'm gonna write that to the side, and then later, eventually, we'll come to consents to add all the summations up in order to get our I sub 2. So again, we're just doing this one by one. I sub 2 1. So we have that it's equal to negative 2. The integral from 0 to pi over 2 of x squared, the natural log of 1 plus cosine of 4x dx. Okay. And now we want to notice that if you graph this function, you're going to notice that there's actually a discontinuity, or rather a singularity at x is equal to pi over 4. So this actually means we actually have to split this integral up into two. So one with the bounds from 0 to pi over 4, and then another integral from pi over 4 to 2. So I'll write that. So therefore, and I'm sure you notice that, again, we're actually witnessing a pattern here. We're going to actually compute more integrals. So this is negative 2, and then from 0 to pi over 4, x squared ln of 1 plus cosine 4x dx, then plus, or minus, this is minus 2 integral from 0 to pi over 2, but this is supposed to be pi over 4 over here. Pi over 4. Okay, and then same integral, x squared ln of 1 plus cosine of 4x dx. Okay, And same thing goes, we're gonna have to label this a second time, and you know, the same process so far. You get the gist. So this is gonna be, I'm gonna call this I sub 2, 1, 1, since we're still at, and then this is I sub 2, 1, 2. So now we have to calculate our I sub 2, 1, 1. So this is gonna be nice and interesting. Yeah, I got plenty of room. Okay, so I sub 2, 1, 1, 1, 1 equals -2, integral from 0 to pi over 4 x squared ln of 1 plus cosine of 4x dx. Okay, now to do this, we're actually going to have to do a u-substitution. So this way, I'm going to say we're going to let u equals 2x, then take derivatives of both sides, so we get du is equal to 2 dx. And now that we have that, so we also have to change our bounds too, don't forget. So over here, so this way we have -2 multiplied by, so new bounds. So we have that x is equal to 0. So as x equals 0, that means u is equal to 0. And then when when x is equal to pi over 4, then that means u have to be pi over 2. And then we need to fill something for x. So that way we substitute it, so we get it in terms of u. So if I were to divide, if I were to solve for x by itself, I just divide by 2. So that means we get that x is equal to u divided by 2. I plug this in here, so it's u squared divided by 4. I can factor out the 4 outside, so I get -2. So I get -2, and then divided by 4. So that's -1 over 2. But then I also have a 2 dx, so divide by 2. So that means I'll actually get a -1 over 4 outside of the integral. Like so. Okay, nice. So now substitute everything in terms of u, so we get u squared, and then multiply by the natural log of 1 plus cosine of 2u du. Okay, and we can rewrite the inside of our natural logs using trig identities. So this is -1 over 4, 0 to pi over 2 of u squared, the natural log. So 1 plus cosine 2u, it's identical, its trig identity is equal to 2 times cosine square of u. Cosine square of u du. Okay, and then now using natural logs, well, for one, yeah, we're actually using natural log rules. So this is a product. So what this means is that yeah, I'm gonna have to move it over here. So this is -1 over 4, 0, 2. So this is u squared, and then this is multiplied by the natural log of 2, and then it's a product. So this is plus the natural log of cosine square of u du. Okay, and then now ln of 2 is just a constant, so I can just simply just move that outside. So this is the negative natural log of 2 divided by 4, and okay, so and then we get that that's the integral 0 to pi over 2. And I'm taking many steps here, but I'm skipping many steps. We can actually split this into 2 integrals again. So the u squared distributes to ln of 2, and then the u squared distributes to the ln cosine square u squared du, and then minus 1 over 4, and 1 over 4, so that means, yeah, and then 0 to pi over 2 of u squared multiplied by ln cosine square of u du. Okay, so now computing this integral is straightforward. So this is simply, you just use the power rule. Again, I'm gonna just skip some steps. So if you were to evaluate this definite integral, you're going to get that it's negative natural log of 2 divided by 4, and then multiply by, well, simplify this out, you're going to get 1 over 3 multiplied by the cube of pi over square, pi over 2, and then you plug 0, obviously you're going to get 0. So if you simplify all that out, you're going to get that it's equal to negative pi cubed divided by 96. And then now, and then don't forget, multiply the ln of 2 with that as well. Okay, so that's what we have. So this is equal to this definite integral. So now using natural log rules, since we have a cosine square, so simply you could just write cosine u and then square that. Using natural log rules, you move the 2 outside, and natural log, that's a constant. I can move that outside, so that means we get negative 1/2, and then 0 pi over 2 of u square, and then ln of cosine of u du. Now it's a good thing we have our facts. So now that we have this, so to put it simply, this is negative square root of pi, negative pi cubed divided by 96 multiplied by ln square, and then this is so minus 1/2 multiplied by negative pi cubed divided by 24 ln of 2 minus pi over 4, and then multiplied by the Apéry constant, which is the riemann-zeta 3. Okay, and this is true because this is by our which number? This is by fact number LU squared. So this is by fact number 3. So I'll put it as let me get my red. This is by fact number 3 that this works. Okay. Now we simplified this out, and we're gonna get that this I sub 2 1 1 is equal to pi cube divided by 96 multiplied by ln of 2, and then now again, you simplify all this out, you're gonna get that it's gonna come down to minus let's see, that's pi over 8 multiplied by the Apéry constant. So there you go. So this is equal to our I sub 2 1 1. Okay, that's nice. And let's see, I'll put our value for I sub 2 1 1 2 over here. Let me see, you guys can see that. Yeah, so I sub 2 1 1 is equal to the following: pi cubed divided by 96 ln of 2 minus pi over 8 multiplied by the Apéry constant, riemann-zeta 3. Okay, cool. So that's a big check for that. So now we have to evaluate our integral I sub 2 1 2. Okay, so now let's calculate the 2 1 2 over here. So 2 1 2 is equal to negative 2 multiply by the integral from pi over 4 to pi over 2 of x squared, the natural log of 1 plus cosine of 4x dx. Okay, so just like before, we actually have to do u-substitution. It's just the same thing from this previous integral just before, but we're actually dealing with different bounds. So let u equals 2x, then du is equal to 2 dx. Okay, so now we want this in terms of u. So let's say I solve this for x. I just divide by 2, so we get that x is equal to u divided by 2. So I plug x equals u over 2, so we get u squared over 2 or u squared divided by 4. I factor out the 4 outside, so we get negative 2 divided by 4, which is negative 1/2. But there's also our 2dx for substitution du, so I just divide that by 2. And so we get that it's negative 1/4 multiplied by. Now we change our bounds, so pi over 4, when that's equal to x, so that's pi over 2 for the lower bound, and then we plug pi over 2 for here, we get that our upper bound is just pi. And so we have u squared, and then the natural log of 1 plus cosine of 2u du. Okay, now we can substitute our input for 2u, or 1 plus cosine 2u using trig form. So put it simply, 2 times the cosine square of u. Alright, nice. So now with that, now let's actually use our natural log rules. Since the input is in product form, we can actually use the rules of addition to separate into two additions of natural logs. Okay, so this means this is negative 1/4 integral from pi, or yeah, that's just pi over here. Pi, and then pi divided by 2. This is u squared, and then so this is ln of 2, then plus ln of cosine square u, then du. Okay, and then now we can actually, using linearity, we can actually split this into 2 integrals. So that means this is negative ln of 2 divided by 4, and then the integral from pi divided by pi over 2 u squared du, then subtract 1/4, and then pi over 2, and this is still just distribute the u squared into here, so it's u squared multiplied by ln of cosine square u du. Okay, and now I'm just going to take this definite integral and skip some steps. Clearly, you can use the power rule, so that we get that it's 1/3 u cubed. You plug pi and pi over 2 for here. Like I said, skipping steps. You're going to get that this definite integral specifically is going to equal to negative 7 pi cubed divided by 96 multiplied by ln of 2. And then subtract with our definite integral over here. So it's 1/4 pi, then pi over 2, then u squared ln of cosine squared u du. Alright, cool. So now all we have left is just to calculate this definite integral. So we're going to actually have to use another substitution. I know, so many substitutions. So we're going to let t, this time we're going to get this in terms of t. So let t equals pi minus u. Okay, then dt is equal to negative du. Also, there's a u squared, so I also want this in terms of t, so let's solve for t, or excuse me, solve for u to plug in so we get in terms of t. So basically, u is just equal to pi minus t. Okay, so we have that. Now let's substitute everything back in, and let's just focus on just the integral itself, and then we'll simplify the rest later. Okay, so u integral. So when I plug pi over 2 for u, so it's pi minus pi over 2, that's pi over 2. And if I plug pi over here, so the upper bound's going to be 0. Okay, so switch the bounds of integration. We end up with a negative integral, but don't forget there's also a negative du. We got to put it in terms for dt, so those negatives cancel out. So basically, everything has been preserved except our bounds have changed. Okay. So that's nice and simple. And how about I actually just rewrite the same integral before, just so I keep track of where I'm at currently. 96, 2, then minus 1/4. Okay, so this is pi over 2. This is 0. and then substitute everything in terms of t. So this is, so we have everything in terms of t, pi minus t square, and then ln of. So if I plug cosine square for u, so put that for in terms of t, so cosine square of pi minus t. So notice the property that cosine of pi minus t in our trig identity is actually equal to negative cosine of t. So if I take that square, so we get the positive, so we're left with just cosine square t dt. Okay. So now we have to expand this part out. So now let's just ignore everything on this side and just focus the integral itself, and then we'll come back and simplify everything else later. Okay, so that means this is let's see, 0 pi divided by 2, and then so we get use FOIL, so pi square minus 2 pi t, then plus t square multiplied by ln of cosine square t dt. Okay, and then now next is that now what I can do is I can actually just use natural log rules. So the exponent can be moved to the front of the natural log, and I can just distribute that outside the integral. Not only that, we're also going to distribute each of these terms into our natural logs, but also we can actually use linearity to actually split into 3 different integrals. So to put this simply, so I moved the 2 outside of the integral, so that means we have that 2 times the integral from 0 to pi over 2 of pi square, and then ln of cosine t dt, okay, then minus 4 pi, then the integral from 0 to pi divided from 0 to pi over 2 of t ln of cosine t dt, and then just factor out the 2 as well, so it's plus 2 times 0 pi over 2 of t square ln of cosine t dt. Alright, so now with this integral over here, let me just get rid of the previous 2 lines so I can make some space. Okay, so now integrating each of these integrals, we can actually use our facts that I've listed. So now the first integral here, this is just simply equal to 2 times pi square multiply ln cosine of t, which is from our fact number 1, so that's negative pi divided by 2 ln of 2. Alright, cool. I'll write the justification later after I expand all this out. So now we have, so this is negative 4 pi, then multiplied by the ct ln cosine t. So this is from fact number 2, so pi squared divided by 8 ln of 2, and then minus 7 over 16 multiplied by the a priori constant. Okay, and that's justified from fact number 2. And then the last one, 2 times this integral, so we can use fact number 3, so plus 2 times, so this is negative pi cubed divided by 24 ln of 2, and then minus pi divided by 4 of our a priori constant. Constant. Okay, cool. And then we just write justified by fact number 1, fact number 2, and then fact number 3. Okay, cool. Okay, and then when I simplified this out, I'm just gonna skip the steps. You can check this yourself if you want to. You're gonna get that this entire expression specifically is just equal to negative 7 pi cube divided by 12, and then multiplied by natural log of 2 plus 5 pi divided by 4 of the a priori constant. Okay, so this is just this expression, but this means that we have this expression. This is equal to this constant, which is equal to this. So we have to substitute our value back into here and then express everything from the rest from here on out. Okay. So that means it's minus. So actually, from previously earlier we had that it's actually minus 7 pi cubed divided by 96, then subtract from 1 over 4 multiplied by everything inside here. Or, my bad, I forgot. There's a multiplied by the natural log of 2 out here. Then minus 1 over 4. And then everything from here. Cubed divided by 12, ln of 2 plus 5 pi over 4 a priori constant. Okay, nice. Now with that, now when I simplify this expression, I get negative. Yeah, I'm back with 7 pi cubed divided by 96 ln of 2, and then I'm just gonna simplify the inside, or not simplify, I mean distribute the 1 over 4 into the inside. So we have that it's positive 7 pi cubed divided by 48 ln of 2, and then over here then it's minus 5 pi divided by 16 multiplied by the a priori constant. Okay, then now simplify this out, then we're gonna get a positive 7 pi cubed divided by 96, then minus 5 pi divided by 16 multiplied by the a priori constant. And now that's actually equal to our I sub 212. All right, cool. So with that, I sub 212 is equal to right here, 7 pi cubed divided by 96, subtract 5 pi over 16 multiplied by the a priori constant. All right, nice. And now all that's left, because we have the following pieces. We have our I sub 21 and our I sub 22. Or excuse me, we have our I sub 21 and our I sub 212. That's what I meant to say. Okay. So going back, so I sub 21 is equal to I sub 211, which is just pi cubed divided by 96 ln of 2 minus pi 8, and then a priori constant 3, then plus I sub 212, 7 pi cubed divided by 96 ln of 2. Yeah, that's supposed to be ln of 2 over here. Let me go back and fix that. 5 pi over 16 a priori constant. Okay, so skipping steps, I simplified this out, and I get that I sub 21 is equal to pi cubed divided by pi cubed divided by 12 multiplied by the natural log of 2. Okay, so yeah, that's good, that cancels. And then subtract 3 pi divided by 16 multiplied by the a priori constant. It's equal to our I sub 21. Okay, nice. So now that we have this, I don't need this anymore. And how about I write what our value of I sub 21 is? 21 equal to pi cubed divided by 12 ln of 2 minus 3 pi 16 a priori constant. Okay, cool. Nice. So we have our I sub 2, 1. Now we have our I sub 2, 2 to calculate. Okay, so going back, now we just have to calculate our I sub 2, 1, I sub 2, 2. So this is just 2 multiplied by integral of pi over 2 x squared natural log of cosine x dx. And in case you haven't noticed that it's actually just 2 times our, we use fact number 3, so it's negative pi cubed divided by 24 ln of 2 minus pi divided by 4 of our a priori constant 3. And then this is simply justified by fact number 3. Okay. Now I simplified this out, so that means I get negative pi cubed divided by 12 ln of 2, then minus pi over 2 divided by the a priori constant. Okay, and then that's just simply equal to I2, 2. Cool. Now I'll just write 2, 2. It's simply just negative pi cubed divided by 12 ln of 12 minus pi divided by 2 of the a priori constant. Okay, nice. All right, so now we have everything to calculate our I sub 2. So reiterate, I sub 2 is equal to I sub 2, 1 plus I sub 2, 2, which is equal to pi cubed divided by 12 ln of 2 minus 3 pi divided by 16 of the a priori constant, then plus negative pi cubed divided by 12 ln of 2 minus pi over 2 the a priori constant. Okay, then simplify this out. You'll get that pi cubed 12 ln of 2, they just cancel, so we're just left with minus 3 pi over 16 and minus pi over 2. Get a common denominator, so it's the same thing as just 8 pi divided by 16, negative subtract, so you're going to get that it's negative 11 pi divided by 16 of multiplied by the a priori constant. Okay, nice. So we have solved our I2. So therefore I2 is equal to negative 11 pi divided by 16 multiplied by the a priori constant. All right, nice. Moving on. Okay, so now all that's left is to calculate our I sub 3. So this is equal to the integral 0 to pi over 2 natural log square of 1 plus cosine 4x divided by cosine x dx. Okay. Okay, now I can just, same thing, like, because there's a square, so I can rewrite this the same as this. So natural log 1 plus cosine 4x divided by cosine x square. Okay. And now we can actually just use the natural log rule. So this is division, so I can write this as a difference of natural logs. 0 pi over 2. This is natural log of 1 plus cosine 4x minus the natural log of cosine x squared dx. Okay, and now we can actually just use the FOIL. So this means this is, and I'm also going to skip some steps here. So, okay, yeah, I'm going to skip some steps. So that means 0 pi over 2, and then this square, and then I can separate this, and I'm just, by using linearity, I can write this with 3 different integrals. 4x dx, then this times this is a minus, so 2 outside pi over 2 of ln square, or not square, just ln. ln of 1 plus cosine 4x multiplied by ln of cosine x dx, and then over here it's plus 0 pi over 2 of the natural log square of cosine x dx. Okay, and with that, let's actually label these with let's label these as I31, I32, and I33. Okay, so one by one, we're gonna have to solve I31. So specifically right here. So I sub 31 is equal to our integral 0 pi over 2 ln square of 1 plus cosine of 4x dx. Okay, and notice that the function is it's an even function. So what I can do is I can actually rewrite our bounds. Well, technically that means we're actually doubling the quantity. Well, excuse me, no, we're not doubling the quantity. We're just rewriting it in a sense so that's such that we have 2 times, and then this time our bounds is actually going to be from 0 to pi over 4 of the same function. Let's see, 1 plus cosine of 4x dx. Okay, and then now we just need to do a u-substitution, so we'll just let u equals 2x, then du is equal to 2du, and then now with that, so we just have to change our bounds of integration. So this means we have, let's see, okay, so I skipped ahead, but you know, you plug 0, so that means u is 0, you plug pi over 4, so you get pi over 2, and then we have that 2 du, so just divide by 2, so just by 2, that'll just be v1. Then we have ln of 1 plus, well, ln square, that's what I meant, ln square of 1 plus cosine of 2u du. Okay, and then again, we can use our trig identities to replace our 1 plus cosine 2u, and replace that with 2 times cosine square u. Okay, so 0 pi over 2, and then ln square of 2 times 2 times cosine square u du, and so because now we can actually use our properties of natural logs to write this as a so because the input is in a product, so we can actually write this as a summation of natural logs. So we have the same bounds, and then this is so, and then don't forget there's a square, so I'll just put the exponent outside. This is simply the same as ln of 2 plus ln of cosine square u, and then square du. And then now what we can do is we can actually just use our FOIL method of the inside, so we get that. And also using linearity, so I can write this as 3 integrals. So this means this is ln square of 2 du, then plus integral pi over 2. This is 2 times ln of 2. Well, I'm just gonna factor out the 2, so it's just 2 times the integral of ln of 2 multiplied by ln of cosine square u du. Okay, and then plus the integral from 0 to pi over 2 of ln square cosine square of u du. Okay, nice. So 3 different integrals we got to calculate. So you know the same drill. So we can actually just label these. So this is I. We're going to call this I sub 311. This is I sub 312, and then over here, this is I sub 313. Okay, nice. But calculating these integrals is actually really simple. Well, obviously for one, the first integral is actually just a constant, so that's not hard to show. But the last 2 integrals, we can actually just use our, eventually we will be using our property, so showing the work is like, it's less of a load compared to the previous. So simply, so let's solve for each one. So I sub 3, 1, so integral over 2 ln squared 2 du. So I'm just gonna save you the trouble. So simply, this is just a constant, so it's u times ln of 2 square. So from pi over 2 to 0, and that's simply just pi over 2 ln square of 2. Okay. Now I'm just gonna write this out so that way it'd be a good reference for later. 311 equals pi square ln squared 2. Okay. Now next integral we got to calculate is I sub 312, and let's see. So this is 2 times 0 pi over 2 ln 2 ln cosine square of u du. Okay, but we can actually take our rules of natural logs. So we can use the exponent 2 and move that in front of the natural log, and that's treated as a constant, so I can just move that outside, so it's outside the integral, and so we get its factor of 4. And then ln of 2 multiplied by ln of cosine u du. And simply, ln of 2 is just a constant, but also we can use the property that ln of cosine of x ds is simply equal to negative pi over 2 multiplied by ln of 2. Okay, so when we simplify this out, we'll get that it's equal to negative 2 times pi multiplied by the natural log squared 2. And let me justify that by fact number 1 that we can actually take the shortcut here. Okay, and then so now I sub 312 is equal to negative 2 pi ln square of 2. All right. Okay, so now the last thing we need to calculate is our I sub 313. Okay, so the following, we have our integral is 0 to pi divided by 2 of ln square of cosine square u du. Okay. In other words, we can actually rewrite this. So this means this is actually 4. How did I get 4? So using natural log rules, the input cosine squared u, so treat the 2 as an exponent, so you can move that outside of the natural log. But because the whole thing is being taken square, so ln square, that also means you have to square the 2 as well, so that's how you get 4, and then simply just move that outside the integral. So 0 pi over 2, and then ln square of cosine u du. But using our following fact that from fact number 4 specifically, that ln squared cosine of x dx is equal to the following. So it's just 4 times pi cube over 24 plus pi divided by 2 multiplied by ln square 2. Okay, and I'll simplify this out 1 sec as soon as I make the justification. This is from fact number 4. Okay, And now to simplify this out, then we actually get that's equal to pi cubed divided by 6. And then, so 4 times that, so this is plus 2 pi ln squared 2. Okay, cool. And then that's our I3 sub 3. Wrong color. So, okay, now I'm just writing what we have. 313 equals pi cubed divided by 6 plus 2 pi ln squared 2. All right, nice. Now we have our following pieces. We have our I sub 311, 312, and 313. So now we can actually just combine our pieces together. So that means our I sub 31 simply is just equal to I311 plus I312 plus I313, which is just well, again, reading back, pi square ln squared 2 plus minus 2 pi ln squared 2, then plus pi cubed divided by 6 plus 2 pi ln squared 2. Okay, cool. And now you just notice that these two terms cancel out. So the only thing we have left is just pi cubed divided by 6, and then plus pi over 2 multiplied by ln squared 2. Okay, nice. So that's our I sub 31. Okay, so I don't need this anymore. So now I can replace. Now I can just write down what we have for I sub 31, which is equal to the following: pi cubed divided by 6 plus pi divided by 2 ln squared 2. Okay, cool. So that's nice. And now I can actually get rid of this. Okay, now up next we have to calculate is our I sub 32. Our I sub 32 is equal to negative 2 multiplied by the integral from 0 to pi over 2, the natural log of 1 plus cosine of 4x multiplied by ln of cosine x dx. Okay, so let's actually just replace our 1 plus cosine 4x with the trig identity, which is just 2 times cosine square 2x. So x. Okay, and then now we can use natural logs since this is a product, so we can write this as a sum of natural logs. So this is negative 2, 0 pi over 2. So this is ln of 2, and then plus make sure ln of cosine square 2x, and then multiply by ln of cosine x dx. All right. And just like before, we can actually just write this, using linearity to split this into two integrals. So now we have that it's negative 2, 0 to pi over 2 of ln of 2, then multiplied by ln of cosine x dx, and then that's also minus 2 times the integral from 0 to pi over 2 of ln cosine square of 2x, and then multiply by ln of cosine x dx. Okay, and then I'll just label these as two integrals. So this is our I sub 3, 2, 1, and then over here is our I sub 3, 2, 2. Okay, so now we have to calculate those. But I sub 3, 2, 1, it has the fall. It's easy to show because not only we have a constant, but we also have a fact that we can justify. So ln of cosine of x dx is equal to negative pi over 2 ln of 2. So I sub 3, 2, 1. Let me just rewrite the same integral we're given. 1 to ln of cosine x dx. That's simply, so I just skipped the steps, so it's just equal to pi multiplied by ln s squared 2, and that's justified by the fact that we use fact number 1 over here. Okay, and so now we have to calculate our also, let me just write to the side over here that I sub 3, 2, 1 is equal to pi ln squared 2. Okay. Now we have to calculate our I sub 3, 2, 2. 2, 2 is equal to, where is it? So negative 2, and the integral from pi over 2 ln of cosine square 2x. And then multiply by ln of cosine x dx. Okay. Now we could just use our rules of natural logs. So simply, since there's a square from this input here, so treat that using natural log rules that can be moved outside. So then we have that's negative 4, and then same as before. This is ln of cosine of 2x, and then multiply by ln of cosine x dx. Alright, now we can actually solve this easily by using the fact that from fact number 5 that ln cosine of ax multiplied by natural log of cosine bx is equal to pi over 2 ln squared 2 minus pi over cube multiplied by the GCD of a and b squared divided by 48ab if the a plus b and over the GCD of a and b is odd. So similar format, a and b, so you let a equals 2 and b equals 1. If we want to show that it's satisfied that it's odd, then we can actually use the formula. So 2, 1, 1 plus 2 is 3, and then the greatest common divisor between 1 and 2, it's equal to 1, so it's equal to 3. That's an odd number, so we can actually use this formula over here. So let me also write that the justification by fact number 5 over here. And then if we plug a and b, so 2 is equal a and b is equal to 1. So if we plug here, that means this is GCD square of 1 and 2. The GCD is just 1. Square that's just also 1. That's also 48 divided by 48 times AB. So 1 times 2 is 2 times 48, so it's 96. So we get that, so it's negative 4 multiplied by, so pi cubed divided by 24, then, my bad, I looked at the wrong one. It's supposed to be pi squared, pi over 2 divided by ln squared 2, then minus, so it's pi cubed GCD of AB squared, so that's 1, and then divided by 48 times 1 times 2, so that's 96. Okay, and then that's simply just equal to, so simplify this out, we get that it's pi cubed divided by 24, and then minus 2 pi ln squared 2. Okay, cool. Now we have that I322 is equal to cube, then 24, then minus 2 pi ln squared 2. Okay. Now we're gonna just erase this. And so therefore our go back to our I sub 3, 2. So I I sub 3, 2 is equal to I sub 3, 2, 1 plus I sub 3, 2, 2. And then we just plug in our constants that are values that we found. ln squared 2, then plus pi cubed divided by 24 minus 2 pi ln squared 2. We simplified this out. We get that it's just pi cubed divided by 24, and then plus or it's supposed to be that's supposed to be a minus. Supposed to be minus pi ln squared 2. Okay, cool. So with that, we have solved for our I sub 3, 2. So I sub 3, 2 equals pi cubed divided by 24 minus pi ln squared 2. Okay, now the last thing we have to solve is our I sub 3, 3. Okay, now the final thing we have to show or solve. So I sub 3, 3, which that's equal to the integral from 0 to pi over 2 of ln square of cosine x dx. But that is easy to see by the justification of fact number 4, that it's simply just pi cubed divided by 24 plus pi over 2 ln squared 2, and that is because of fact 4 here. Okay, so now we have our I sub 3, 3. So I 3, 3 is equal to pi cubed divided by 24 plus pi divided by 2 ln squared 2. Okay, so now we have our pieces. Okay, now I can actually just get rid of this. Did not mean to erase that. So going back and reiterate, so I3, which is equal to the integral 0 pi over 2 ln square of 1 plus cosine of 4x divided by cosine x dx. So simply just plug in our values. So I sub 3, 1 plus I sub 3, 2 plus I sub 3, 3 is equal to pi cubed divided by 6 plus pi over 2 ln squared 2. Let me fix this parentheses over here. Then plus pi cubed divided by 24 minus pi times ln squared 2, then plus pi cubed divided by 24 plus pi over 2 multiplied by ln squared 2. So if we simplify this out, so let's see, pi over 2 plus pi over 2, so that's pi ln squared 2, and then minus that, so that term cancels. So we only have these two terms to focus. So let's see, we can get a common denominator, so it's 4, and then plus, and then plus here, so that means, and this, I forgot about this term here. This term we're focusing on. So that way see, that means we get 6 pi cubed divided by 24. In other words, that simply just simplifies to pi cubed divided by 4. Okay, nice. So that means over here, I sub 3 is equal to pi cubed divided by 4. All right. So I can get rid of everything here. We solved everything we need to solve. Okay, now just to reiterate everything we have. So that means we're given that the integral 0 to pi over 2 of ln square of e to the negative x squared divided by cosine x multiplied by 1 plus cosine of 4x dx. Okay, that's simply just equal to I1 plus I2 plus I3, and just plug in our values, so we get that's pi to the 5th divided by 160 plus, or rather minus 11 pi divided by 16 multiplied by the Apéry constant, and then plus pi cubed divided by 4. And there we have it. That's our final conclusion, or final answer to this monstrosity, this integral. And there you have it. Told you it was going to be lengthy.